Beneath your backyard right now, there's enough electrochemical energy sitting in the soil to run a small sensor for years, using nothing more than two metal rods and the dirt under your feet. No panel, no compressor, no lithium, no bill. Hobbyists and off-grid tinkerers have started calling this thing the $50 machine that pulls electricity from the ground forever. And every comment section under every Earth battery video is stuck on the same argument. Is this real power generation or a party trick dressed up as free energy? If you're into forgotten low-tech energy hacks, this channel exists to dig them up. So subscribe if that sounds like your kind of thing, because this one gets stranger the deeper you go. To understand what's actually happening in the ground, you have to go back to the 1840s, decades before Edison, decades before any public grid existed. Telegraph engineers building lines across Europe and America ran into an expensive problem: copper return wires. Every circuit needed two of them, one to send the signal and one to complete it. Then engineers noticed something strange. Bury a metal plate at each end of the line instead of running a second wire, and the earth itself would complete the circuit. A plate of the same metal at each end just closes the loop. It lets an external battery's current pass through the ground instead of a wire, nothing more. But bury two different metals, and the ground itself starts producing current with no external battery attached at all. Scottish inventor Alexander Bain patented exactly this in 1841, pairing zinc or copper plates in moist earth, and by the 1870s, stretches of the American telegraph network were running partly on these dissimilar metal pairs. Engineers of the era called it, literally, the Earth battery. For decades, it stayed a footnote in telegraph history, pushed out by cheaper copper and later by proper chemical batteries. But the underlying phenomenon never stopped being real. It just sat dormant, waiting for someone with a soldering iron to dig it back up. So what's actually generating the current? It's a galvanic cell, the same basic chemistry as a potato battery or a lemon battery, just scaled up using the biggest, most available electrolyte on the planet, the ground itself. Three things are happening at once. First, electrochemical potential. Put two different metals into a conductive medium, say a zinc rod and a copper rod, and the two sit at different points on the electrochemical series. Zinc gives up electrons more readily than copper. That difference in willingness to let go of electrons is what creates voltage between the two rods. Second, electrolyte conductivity. Dry soil is a poor conductor. Soil that holds moisture, especially soil rich in dissolved minerals and salts, becomes an effective electrolyte, letting ions migrate between your two buried rods and complete the circuit, similar to how the acid in a car battery works. Third, the corrosion current itself. As the reaction runs, the more reactive metal, usually zinc, magnesium, or aluminum, slowly oxidizes and dissolves into the soil atom by atom, releasing electrons that flow through your wire as usable current. Those are the same electrons that light an LED, trickle charge a capacitor, or power a small sensor. The real-world numbers back this up. Documented amateur builds using a zinc rod and a copper rod, spaced a few feet apart in moist, mineral-rich soil, have reliably produced between 0.8 and 1.1 volts open circuit, with currents in the microamp to low milliamp range. Soil moisture researchers have used this exact setup to power ultra-low draw environmental sensors continuously for over a year without swapping a single battery. Swap the zinc for magnesium, similar to the sacrificial anodes that protect ship hulls from corrosion, and the cell gets noticeably stronger. Magnesium sits further from copper on the electrochemical series than zinc does, which pushes open circuit voltage up to somewhere around 1.5 to 1.6 volts. roughly half again what a zinc-copper pair delivers. That's real, measurable, continuous electricity, generated for the cost of two metal rods, a stretch of wire, and a shovel. Total materials for a basic build, under $50. Field researchers doing remote agricultural monitoring have leaned on this for years, mostly because sending someone out to swap batteries in a field with no cell signal is a logistical headache nobody wants. A buried electrode pair that does its job for a year with zero maintenance and zero moving parts solves a problem solar panels actually struggle with in the same conditions. A panel needs clear sky and regular cleaning. A buried rod needs neither. Every viral Earth battery video leaves one thing out of the thumbnail. Forever is doing a lot of work in that title. The reaction that generates your current is the same reaction eating your electrode. Zinc or magnesium doesn't produce electricity out of nothing. It produces electricity by dissolving. Depending on soil moisture, mineral content, and electrode size, a basic setup might run strong for 6 months to 2 years before the sacrificial metal wears down enough that output collapses. You can stretch that with a bigger electrode or periodic replacement, but the honest version of the title is this machine pulls electricity from the ground until the metal runs out, and that doesn't get nearly as many clicks. There's a second limit worth knowing about if you're picturing this powering your house. The output ceiling is low. We're talking microwatts to a few milliwatts, enough for a sensor, an LED, or trickle charging a supercapacitor, and nowhere close to what a fridge or a phone charger needs. So why hasn't any utility scaled this up? It's not suppression, it's just that the physics doesn't scale the way solar or wind does. A bigger rod doesn't get you proportionally more power. Past a certain size, the reaction plateaus, limited by how fast ions move through the surrounding soil. Scaling this to household power would take an absurd amount of sacrificial metal on a punishing replacement schedule for a return that never pencils out. It's a low-power, long-duration trickle source. The technology has known that about itself since the 1870s. Should you actually build one? If you're running remote soil sensors, a small weather station, an off-grid trail camera, or anything drawing a few milliwatts continuously, this is a genuinely elegant, nearly maintenance-free option and one of the cheapest forms of continuous power generation out there. If you're picturing it replacing your utility bill, it'll disappoint you the way a AA battery disappoints someone trying to run a table saw. If you want to build one, the setup is almost embarrassingly simple. Get a zinc-plated ground rod or a magnesium anode, the kind sold at any hardware store as a water heater sacrificial anode, and pair it with a copper grounding rod. Bury them 2 to 3 feet apart in soil you keep consistently moist. Adding a mineral-rich amendment like Epsom salt around the electrodes boosts conductivity and output, but it's a real trade-off, not a free upgrade. More dissolved salt means a more aggressive electrolyte, which speeds up the same corrosion reaction that generates your current. A heavily salted bed produces stronger output for a shorter total lifespan, while a lighter touch trades some peak power for years of extra runtime. Connect both rods to a low-voltage energy harvesting circuit, the same kind used in solar micropower projects, which stores the trickle in a capacitor until there's enough charge to do useful work in short bursts. The Earth battery isn't a scam. It isn't a myth either. It's a real, documented, nearly 2-century-old technology doing exactly what basic electrochemistry says it should, and nothing more. It didn't get abandoned because it failed. Copper wire and centralized power just got cheap enough that a free but tiny trickle of current stopped being worth the trouble for everyone except the people who genuinely need a sensor to keep running, untouched, in the middle of nowhere for a year at a time. If digging into how these forgotten, unglamorous little technologies actually work is your thing, That's what this channel does, so stick around. Next time, we're staying on the theme of power you can actually own outright, looking at a plug-in setup that delivers real, usable household electricity for a tiny fraction of what a full rooftop solar installation costs.